Okay, so I guess this is the next question. So now we are given to this function that we need to optimize. Okay, so I'll just write in short for now. Like let f of x1 x2, it has only two variables, no, be equal to 4x1 plus 8x2 minus x1 square minus 2x1 x2 minus 2x2 square. Nice. This is our function to be optimized. So let this be the function to be optimized. Also, we can let our constraint h1 be equal to x1 plus x2 minus 4. We get that from here, and we also have the condition that x1 should be greater than equal to 0, x1 x2 basically. x1 x2 should be greater than equal to 0. Now we can go ahead and define our Lagrangian function. Lagrangian function. Okay, so now a Lagrangian function looks somewhat like this. Okay, x1 x2 and lambda 1. Lambda 1 because there's only one constraint. If there were two constraints, then there would be lambda 2 as well, and our two variables. So it's defined as our function minus lambda 1 times whatever constraint we have, h1 here in this case, which simplifies to, after we substitute, 4x1 plus 8x2 minus x1 square minus 2x1 x2 minus 2x2 square minus lambda 1 into h1. H1 is x1 plus x2 minus 4. Correct. Now see, we have 1, 2, 3. So we need to find derivatives with respect to this. Derivatives of a Lagrangian function. And then we put them equal to 0. That is, we need to find this, we need to find this, and we need to find this. Okay, so let's get started, shall we? So for this, firstly we differentiate this with respect to x1. So we get 4 minus 2 x1 minus 2 x2 minus lambda 1 equal to 0. Now if we differentiate this with respect to x2, we get 8 minus 2, okay, 8 minus 2 x2 minus 4 x2 minus lambda 1 equal to 0. What is this? Is this x1? Wait, what? Minus 2, yeah, this should be x1. Minus 2 x1 equal to 0. Okay. And then we have del L by del lambda 1. This is basically just our constraint, x1 plus x2 minus 4 equal to 0. Now I'll be using my calculator to solve our equation 1, 2, and 3 simultaneously. Simultaneous. 3 unknowns, x1, x2, and lambda 1. So our first equation, the coefficients will be minus 2, minus 2, minus 1, and this 4 will go here. So minus 2, minus 2, minus 1, and minus 4. Minus 2, minus 2, minus 1, and minus 4. Nice. Then for the next one will be minus 2, minus 4, minus 1, and minus 8. Minus 2, minus 4, minus 1, and minus 8. Lastly, we'll have 1, 1, 0, because there is no lambda 1 here. 1, 1, 0, and this minus 4 gets shifted to the other side. So we get 4. 1, 1, 0, and we get 4. So on solving, we get x is equal to 2, means x1 is equal to 2, x2 is equal to 2, and lambda 1 is equal to minus 4. x1 is equal to 2, x2 is equal to 2, and lambda 1 is equal to minus 4. There is no use for lambda 1 at this point, so we just ignore it. We take our stationary point though, that's very useful, which is 2, 2. Now we need to check whether at this point our function is maxima or minima. Okay, like whether this point is a point of maximum or minimum, whether we get the maximum value from a function or the minimum value from a function. So now we have two variables and one constraint. So we'll be calculating the del 3 wala matrix, which looks something like this, I guess. So we have 0, del h1 by del x1, del h2 by del h1 by del x2, Here we have del h1 by del x1, del h1 by del x2. Here we'll be differentiating a Lagrangian function del square x1 square, del square L by del x2 square. Then we'll have del square L by del x2 x1 del x1, and over here it will be reversed. Okay, so we'll have del x2 x1, basically x1 first then x2. वैसे. Nice. So now we just need to calculate this so that we can just have a quick look at our function, Lagrangian function, that is. Our Lagrangian function is this. We already have del x. First let's look at the constraint. Okay, this is our constraint. So our del h1 by del x1 is 1, as you can see, and our del h1 by del x2 is also 1. Nice. Now let's look at a Lagrangian function. Now for that, we first need to calculate del square L by del x1 square, no? Like second differentiation. So we could just differentiate with this with respect to x1 again. We'll get -2. For the second one, that is del square L by del x2 square, that we could get by differentiating this with respect to x2 again. We get -4. And now we also need del square L by del x1 x2. First x1, which is here, and then this x1 should be differentiated with respect to x2. Sorry, x1 x2. So if we do differentiate with this with respect to x2, we get -2. Similarly, we need to calculate del square del x2 del x1. Basically differentiate with respect to x2 first, and now we differentiate this with respect to x1. We get another -2. Nice. So now let's just substitute the values over here. We get 0, 1, 1, 1, 1. I think this was -2, -2, -2, and this was 4. Or -4. Wait, let me check. -4. Correct. Yeah, okay. Now I'll just put this matrix into my calculator and let it sit for solving. 0, 1, 1. 1, -2, -2, 1, -2, -4. See? Same matrix now. Now we just go into matrix calculations. Then determinant, matrix. We get 2. We get a positive determinant value. Okay, we got 2 now. Positive. Since it's positive, that means this point is a point of maxima. If you had gotten del 3 as negative, then this point would be a point of minima. But since we didn't get that, we got this now. So this is a point of maxima, that is a point 2, 2, a stationary point 2, 2. Now we can just substitute this into our function and get the value. So let's get to the substitution now. That's the easiest part, I guess. Yep. So we get the maximum value of this function as 4. That is with the constraints. Okay, like this is the maximum value while still obeying the constraint. Our constraint was this door. So based on the given constraints that x1 plus x2 should be equal to 4, that is 2 plus 2 we got now. So 2 plus 2 is 4, correct? So that based on that constraint, the maximum value of a function is 4, and that's the answer.